3, 2, 1, let's go! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're going to be talking about the Weakmap object in JavaScript. Now, if you're already familiar with how the map object works, this is going to be a no-brainer. And if you're not familiar with it, it's going to be a no-brainer again because it's really easy to use. It just simply associates an object with a particular value within a map system so that you can retrieve that information later on. Want to see how it works? Let's get started. So what I want to talk about here on the Weakmap is 4 different methods: the set, the has, the get, and delete. You know those 4 methods, you pretty much can do anything you want to with a Weakmap. So first of all, what is a Weakmap? Well, a Weakmap is a way to associate a key with a value, and it just basically is a dictionary of those key and values. Now the important thing about a Weakmap is that the key itself must always be an object. And that's opposed to if you're working with a map's key could be an object, it could be a string, a number, it could be absolutely anything. But with a Weakmap, it can only be an object. And in our next section, I'll tell you exactly why that is. So to create a Weakmap, that's all there is to it. This creates an empty dictionary object or dictionary map. I'm going to create 2 different objects here, one called my cat and my dog, to take a look at all these different ways to be able to manipulate this dictionary object. So now we've got all that set up, we've got our objects and we've got our dictionary, the Weakmap. Let's take a look at the 4 different methods. The first one is going to be set. And set is the method to be able to associate a value with a key and to put that within the dictionary. So in this case, I'm going to take the my cat object, which I have defined here in line 2, and associate it with the value, this object here with the value location home. So that anytime I'm going to retrieve my cat, I can always just say, hey, my cat, get the information from the dictionary for my cat, and it will return location home. That's set, and that's really all set does. Set takes the object and associates it with something else. Now, does the value have to be an object? No, it can be absolutely anything. Just the key has to be an object. So that's set. Well, how do we find out whether our dictionary object contains a particular key? And that's with the has method, which you can see here on line 6 and line 9 and line 11 and line 14. And has will return a Boolean true or a Boolean false depending upon whether that particular object is within the dictionary. So in this particular case, I have already set my cat within the dictionary. The dictionary has 1 entry, my cat, so I know that my cat is there. So I would expect line 6 to print out yes in this particular case. When we get to line 9, however, it's going to ask for, does it have my dog? Well, I know I haven't put my dog in there yet, so I should expect line 9 to print out no. So again, has returns a Boolean true or Boolean false whether that object is within the dictionary or within the Weakmap itself. The next one to take a look at is get. And get retrieves that object from the dictionary. So in this case, on line 7 here, I'm using get to get the information for my cat from the dictionary. Now what's going to get returned will be the value right here. If you look at line 5 again, the value itself will just be, in this case, just the 1 key within an object called location. So what I'm going to do here is I'm going to get my cat, which will get the entry for my cat, and print out the value of location. What if that entry isn't in, or that object is not in the dictionary? It will return null. It won't error out, it will just return null. And finally, the last thing I want to take a look at is the delete method. The delete method removes that entry from the dictionary. So in this particular case, on line 10, I have set my dog into the dictionary. That it adds my dog into the Weakmap dictionary, but then I'm deleting it right back out on line 13. And it just simply pops it back out. And that's going to be extremely important as we go on a little bit later on. Now, let's take a look at what the program does. First, I'll set my cat, and I'm going to use the has to be able to say, does this cat exist or not? So it should print out yes the first time. And then I'm going to use get to get the location or the value of that particular cat. In this case, it should be home. So I should have it, so it should say my cat location home. Then I'm going to ask it, is the dog there? Of course, the dog's not there. So I'm going to add the dog. And then I'm going to ask again, hey, is this dog still there? And it's going to say, yes, still you do now, or nope, it's still not there. I should expect it to say, yes, you do now at this particular point in time. Finally, at line 13, I'm going to delete my dog, which means it should be gone. So it should print out, wow, the dog is gone. I like dogs. So while the dog is gone, that will print out because now dog is not within the dictionary. Want to see how it works? Sure you do. So let's go over to Node and let's type in node get. And sure enough, yes, do I have a cat? Yes, of course we have a cat. That's what we originally told it that we were going to have. The cat's location was home because that was the, if we flip back over to the code here, that's what we said in, what we set, excuse me, inside in line 5 here was that the location would be home. Let's flip back over to Node. Do I have a dog? No, of course not, because the first time I didn't. So then I added the dog. And now it says, well, how about now? Well, yes, you do. Well, then I deleted the dog and it says, well, check again. How about now? Wow, the dog is gone. And that's it. That's really all there is to a weak map. So one of the questions that you get here is that if you're used to working with JavaScript and you're used to working with maps, what is the difference between a map and a weak map? I mean, why even have a weak map if map will do everything for you? In fact, even map will do more because map can have keys that are not objects. Well, there is a giant, really important difference between weak map and map, and we'll show you that next. So what's this big difference between weak map and map? Well, it all has to do with what we call garbage collection. Now, one of the great uses of weak map is to create a private variable within a class, and I've got an example here on my class animal here of how we're using a weak map to create private variables. Now, I know what you're saying. Private variables are going to become part of the JavaScript language here within the next, I don't know, probably a year or so, and that's fine. But from what I read, private variables is nothing more than sugar on top of weak maps. So what I'm showing you here is the best way of doing it for right now if you want to be cross-browser compliant and all that kind of fun stuff. Doesn't matter. Anyway, so we create our weak map out here outside of the exporting of the class of the animal, but when I construct the animal, I am setting within that weak map the this variable. Remember, this is an object because I can only have objects as my weak map. By setting this up here, I can now have a value, in this case of random age, within the private map, which is our weak map. So what happens here is that the person who consumes animal, all they can see is name and age. They can't see random age because they can't see the private map here. All they can see is the animal class. It's just the way JavaScript works, and that's great. So I now have a routine here within, or a method within my animal class to be able to retrieve that private age. And to retrieve that, I just simply use the get on this, because remember, this is an object, and I get the random age. And this works exactly like our my cat and location did on our previous section of the video. And that's basically it. And then just for fun's sake, I have a little static get map size, which returns the size of the private map. Now, in reality, this will bomb out. This part will not work here because there is no size variable on weak map, or size property, excuse me, on weak map. I have that in there to show you why you want to use why you would want to use a weak map instead of a map. What I'm going to do here is I'm going to go back to line 1 and I'm going to change this to map. And so I'm going to now use this as a regular map into animal, which will work exactly the same way. So the idea here now is that I'm going to flip over to my program, and this is the map program I'm going to run for the example here, and I'm going to create 200 different cats to be able to throw into my zoo. And again, I'm importing animal from animal, and I'm going to create 200 different ones with 200 different animals within the zoo here. I'm going to use the get map size to be able to show you how big this map is to begin with, and because size is a property on the maps, not on weak map, but on map, size is a property. Then I'm going to delete 195 of them straight out. That's only going to leave 5 entries into our zoo object here, because I'm going to be deleting 195 of them. Then I'm going to wait 5 seconds, and I'm going to say, well, here's the new map size, and then here are all 5 of my animals. So basically what happens when I delete a variable in line 13 in JavaScript, it's going to not physically just delete it out there, but it's going to mark it for deletion. then at a certain period of time, within the cycle, it's going to go through what's called garbage collection. And it's going to say, oh, okay, this variable has been marked for deletion. Are there any references left into it anywhere? No references? Okay, wipe it out. And it physically at that point removes it from memory. But as long as there is a reference available to it, it's not going to wipe it out of memory. And that's the real kicker here. That's the real key, is that as long as there is at least one reference somewhere within your JavaScript code to that particular variable, it will physically not delete it out of memory. Now, it means you can't access it. I mean, it deletes it. You cannot access it ever again. But physically within memory, it is still there because there still could be a reference. And that's going to be the problem with using on the map. So let's actually see what happens here. After 5 seconds on the set timeout, that 5 seconds is plenty of time for garbage collection to run. I'm going to rerun to say how big is my map size, and it should return 5, and then I'm going to show you all the different animals in the zoo, and it should return 5. So first time through, I should expect to be 200. After 5 seconds, it should be 5 for the size, and then all 5 of the animals. Let's go over to node, and let's type in node map. And it's 200. Now we wait our 5 seconds. Boom. Aha. Notice what's happened here. Here are my 5. These are all the different animals in the map. There's only 5 animals in the map. But according to JavaScript, the size of the map is still 200. So although we can only access 5 of those entries within the map, we still have memory allocated for 195 others. What's the problem here? This is what's called the classic example of a memory leak. Because there is one reference in that map to this object, JavaScript cannot delete this object from the map, so it keeps it open. You cannot access it ever again, but it keeps it there and it keeps it in memory. And obviously, if you go through 10,000, 100,000, a million of these different animals, you're eventually going to run out of memory, because your map's going to get bigger and bigger and bigger because it cannot delete those references. And that is the usage of a weak map. So if I flip back to the code over here, all I got to do is go back to animal and type in the word weak map. A weak map basically weakly couples the key, so that when that particular key somewhere inside JavaScript is deleted and the garbage collection is run, JavaScript's going to take a look at it and say, oh, I've got a reference inside a map here. Oh, but this is a weak map, so I can go ahead and delete this reference too. So you have absolutely no control whether that reference within the weak map gets deleted or not. And because of that, because it's variable, because garbage collection at any time can take it out, that's why there is no size variable inside of a weak map. So for instance, I've got the weak map now, it should run, but if we flip over to node and we run it one more time, it's going to bomb out on us. Well, actually, it's going to say undefined. Undefined because it has absolutely no idea of how large this weak map is. So that is why you use weak maps if you're going to be using things like private variables, or if you're going to be using variables that you know could be deleted by another process somewhere else. If you always use a weak map, that means that JavaScript will be able to do garbage collection and wipe out that weak map and take care of that memory for you automatically without you having to figure out to do it yourself. If you use map and you don't control when objects get deleted, you're going to have a memory leak problem. So that's the giant, huge difference between map and weak map. Weak map will automatically adjust itself during the garbage collection cycle, while map will not. So use weak map whenever you need to have JavaScript take care of the garbage collection for you. And that's all there is on the usage of Weakmap. I hope you enjoyed our video. Hope it didn't bore you to death. Please view all of our videos at www.boringjavascript.com. Subscribe to our YouTube channel, or check out everything we have at www.thevirtualoid.com. Thanks again for watching, and we'll see you later.